Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Ahmad Redza Iezlan bin Ahmad Faisal from the school SMK Abdul Rahman Talib from 4 Gigih, and I would like to present the effects of gravity on the growth of humans. This video will contain 7 parts, which are: what is gravity, the difference in density, bone fragility, the size of the lungs, the blood circulatory system, blood pressure, and finally a conclusion. Very well, to begin, what is gravity? Gravity is the force by which a planet or another body draws objects towards the center. As everyone knows, Earth has a gravitational force of 9.81 meters per second square. Some planets, such as Mars, have a weaker gravity compared to Earth, being only 3.71 meters per second square, while some planets, like Jupiter, have a stronger gravity than Earth, which is 24 meters per second square. Moving on, the difference in density in a low gravitational atmosphere, the density in the muscles are different, in which the low gravitational pull puts less strain on the muscles. For example, while I may weigh 120 kilograms on Earth, on the Moon I might only weigh 40 or even maybe 30 kilograms. Thus, the gravitational strain on the muscles is less, and the muscles grow less dense. This can result in a muscle loss of 3 to 10%. In contrast, in a strong gravitational atmosphere, muscles have to grow denser in order to compensate for the stronger gravity. Using the example just now, while I may weigh only 120 kilograms on Earth, on possibly Jupiter, I might weigh as much as 240 kilograms. So, the muscles have to grow denser in order to support the higher weight in the stronger gravitational atmosphere. Next is bone fragility. Similar to muscles in a low gravitational atmosphere, bones also grow less dense in low gravitational atmospheres because they do not have to support as much weight as they do on Earth. Thus, they grow less dense than they would on Earth, and subsequently, they would become more fragile than they would in Earth's gravity. Likewise, in a strong gravitational atmosphere, the bones in our bodies would have to grow stronger and denser in order to compensate for the great gravitational strain being put on the bones. Thus, because they are stronger, they also grow denser, and when they grow denser, they also grow heavier. Moving on to the size of the lungs, in low gravity, such as the Moon or, as I have previously mentioned, Mars, there is much less oxygen than there is here on Earth. Thus, because there is less oxygen, the lungs will experience shrinkage as there is less oxygen to inhale. This can be seen, for example, in astronauts in space. Meanwhile, in a strong gravitational atmosphere, though there is greater gravitational strain on the lungs, this does not affect the lungs' size. Because of this, the size of the lungs stays normal than that if they are on Earth. Next is the blood circulatory system. In low gravity, the blood circulatory in the body is disrupted. This is because without gravity, there is no blood to be weighed down to the lower portions of our body. Thus, the blood circulatory system is disrupted and the circulation is reduced. And because of this, the heart grows weaker because it does not have to work as hard to pump blood throughout the body. In sharp contrast, in strong gravity, the blood in our body will be pulled down to the lower half of our body. Because of this, the heart has to work a lot harder in order to pump blood to where it needs to go, such as the brain and the upper half of the body. Thus, the heart has to work a lot harder, and this results in a stronger heart. Finally, we have the blood pressure in the human body. As I've previously mentioned, in a low gravity scenario, there is not enough gravity to pull blood to the lower portions of the body. Thus, blood starts to naturally go upwards to the upper half of our body. In strong gravity, however, the opposite is true, in which more blood is being pulled downwards to the lower half of our body. Thus, the blood starts to pool in the lower half of the body. In conclusion, the human body has evolved over thousands of years to adapt to Earth's gravity. Thus, we will have to work together to overcome the challenges presented by different planets and their gravity, as well as their other unique conditions. Very well, that is all from me. Thank you.